Injection molding is the most common method of producing parts out of plastic material. The process involves injecting molten plastic at high pressure into a mold shaped in the form of a part. Once this plastic cools and solidifies, the mold opens and the part is ejected. Injection molding is an extremely versatile process that can produce parts with holes, springs, threads, hinges, and undercuts in a single operation. Injection molded parts can be simple or complex, and can be solid, foamed, reinforced, or filled. They can be small or large, thick or thin, flexible or rigid. Injection molded parts also lend themselves to endless decorative effects. They can be polished, textured, hot stamped, plated, colored, or clear. No other manufacturing process offers the range of capabilities injection molding provides. Injection molding machines range in size and complexity from desk-size units up to machines the size of a small house. All injection molding machines are a combination of two systems, an injection system and a clamping system. The injection system heats the thermoplastic material to its appropriate viscosity or flowability and then forcefully injects it into the mold. There are two types of injection mechanisms: the reciprocating screw, which is the most common, and the two-stage screw. The main parts of the reciprocating screw injection system are the hopper, a reciprocating screw inside an externally heated injection barrel, a hydraulic motor, and an injection cylinder. Resin material is fed to the injection barrel from the hopper. These hoppers may be filled manually or vacuum-fed automatically, and often have dryers attached to the top to remove the moisture from the material. As the resin enters the injection barrel, it is driven forward by the rotation of the screw, which is powered by the hydraulic motor. The resin plasticizes or melts as the turning screw drags it towards the nozzle end. This is referred to as drag flow. Drag flow causes the polymer molecules to slide over each other, creating frictional heat, which melts the material. External heating bands provide additional heat to the injection barrel. The heating bands bring the material to its final temperature and compensate for the radiation heat loss. The temperature is controlled by 3 thermocouples in the barrel and 1 in the nozzle. The screw consists of 3 zones. The first zone, which is 1/2 of the screw, is called the feed zone. It has a constant flight depth, which forces the material together and rids it of air. The second zone, called the melt zone, has a decreasing flight depth, which reduces the plastic volume. This causes the plastic molecules to rub harder against each other, plasticizing the material. The melt zone leads to the third, or metering zone. The metering zone has a constant flight depth much smaller than that of the feed zone. This section acts as a pump. The tip of the screw has a one-way valve which lets the material flow only towards the nozzle end. The force of the plasticized material pushes the screw back as it turns. This builds a chamber of plastic in front of the screw. When enough material for the injection shot is melted, the screw stops and pulls back to decompress the material. For injecting the material, the one-way valve closes as the screw is hydraulically pushed forward by the injection cylinder. This sends the molten material through the injection unit's nozzle and into the injection mold. The primary speed and the injection pressure, called the packing pressure, is high, usually around 20,000 psi, but sometimes reaching up to 30,000 psi or higher. A secondary lower pressure is applied shortly after the initial injection. At the time of injection, the material's temperature ranges from approximately 320 to 600 degrees Fahrenheit, or 160 to 320 degrees Celsius. Once the plastic solidifies, no more pressure can be exerted upon it in the mold. The reciprocating screw then begins to rotate again, melting material for the next shot.